There.
All right, so today we're going to talk about the order of operations. Now, the order of operations you've probably learned as PEMDAS, or please excuse my dear Aunt Sally. I use a different system. It's the same, only different. I use the four letters P, E, D, S. So what do you think the P stands for? Yes? Parentheses. The P is parentheses and other grouping symbols. So parentheses we know look like this. But when we get more complex, we might also use what are called brackets, and that's the next word, and braces. The curly ones are called braces. There's also other grouping symbols that we don't necessarily think of as grouping symbols, like the numerator and denominator of a fraction. You have to do the entire numerator and the entire denominator of a fraction before you can move on. This becomes a grouping, a parenthesis, if you will. It's part of a grouping symbol. And this is part of a grouping symbol. You have to do everything inside according to the rest of the order of operations before you can move on. What do you think the E might stand for? Yes?
Exponents.
Exponents. Exponents are neat insofar as, let's say, we have 10 to the third power. All right? Very powerful, isn't it? Because that actually stands for 10 with how many zeros after it? 3. 1, 2, 3. That's 1,000. But there's something interesting about the way I do this. E stands for exponent. It also stands for something called its inverse operation, which is a, what undoes an exponent? What would be 10,000? How could you make 1,000 back to 10 in one step? Yeah. It's not actually division. It's something called a cube root. The third root of 10,000 equals 10. So this happens. To undo it, you have to take a root. So the inverse operation of exponents are roots. So that's what the E stands for. Exponents and its inverse, roots and radicals. This is a radical sign. All right? What do you think D is? Yeah. Division and multiplication. Again, we're talking about, and I'm going to use tens again because I like the way they show something. We're talking about inverse operations. So 10 times 10 is 100. What's 100 divided by 10? 10. So you see how you can multiply and then you can undo it with division. That's what an inverse operation does. It does things and then it undoes it. That's all inverse is. So D stands for division and multiplication. What do you think S stands for? Yes, over here. Subtraction and addition. So, again, let's use tens. 10 minus, I'm going to use a different number, 5 equals 5. Oh. Now let's do it this way. Always do something wrong in the video. 10 plus 10 is 20. 20 minus 10 equals 10. Okay? And that's subtraction and addition. So, what do you think is the most powerful of the orders? Exponent, exponents and roots and radicals, division and multiplication, or subtraction and addition? What does the most the fastest? Yes?
Multiplication.
Does multiplication make the biggest number the fastest?
No. Exponents.
What do you think?
Exponent.
Exponents. They're pretty powerful, aren't they? They make something so big, so fast. What comes second? Multiplication. And then finally? Addition. So if you can keep track of exponents, make them bigger, faster. Multiplication makes them bigger, the next fastest. And addition makes them biggest, the least fastest. Then you know what order operations has to go in. It makes the most sense. The other thing you need to keep track of is whenever you're working a problem, and we're going to do those with examples, you always have to move from left to right by order of operations. So exponents and radicals, do all of them from left to right. Doesn't matter which one you do, exponents or radicals, but do them all from left to right. Then do division and multiplication from left to right, and subtraction and addition from left to right, after you've done everything in the parentheses. Questions? Thank you.